Hi, everyone. In this video, we're going to begin a new fair division method. This is going to be the lone divider method, and this is for continuous fair division. So continuous fair division games with 3 players. So we saw divider chooser, which was for continuous fair division games with 2 players, and now we're going to do the same thing with 3 players. And in fact, this method scales up, so it can be done with 4, 5, 6, etc. players, but it gets much more complicated, and so we're only going to talk about it with 3 players. And there are other methods for continuous fair division with 3 players. There's several out there. This is the only one we're going to discuss, though. So the lone divider method for continuous fair division games with 3 players. So first thing you're going to want to do, let me just get right into the method. So decide on one player to be the divider. And this should be done randomly. Because just like for divider chooser guaranteed exactly 50%. Divider chooser for 2 players guaranteed exactly 50% of the total value for the divider, whereas the chooser could get 50% or more. So divider got exactly 50%, chooser got at least 50% in their opinion. And so just like for divider chooser for lone divider method, the divider is always going to have 33 and 1/3% of the total assets in their opinion, whereas the other 2 players could get more. And so decide on one player to be the divider. And so the divider divides the asset into 3 shares that are each worth 33 and 1/3% of the total value in the divider's opinion. Okay, and so when we have a fair division game with 3 players, every player is entitled to 1/3, or what they believe to be 1/3 of the total value of the assets. And so 1/3 is the same as 33 and 1/3%. Okay, now the other 2 players, so step 2, the other 2 players, the choosers, now make bid lists, what are called bid lists, where they list every share they consider fair. So essentially, the other 2 players, they look at the 3 shares that the divider has made, and they say, that share is worth, to me, that's worth at least 33 1/3. That's fair. The second one, that's not fair. That's worth less to me. And the third one, that's fair to me. And so they all make bid lists on where they just list every share that they consider fair. Now, an important thing, they can't just pick their favorite share. They have to pick one that they actually they have to pick everyone they consider fair. Now, with this method, they might not get their favorite share, but they will get one that they consider to be at least 33 1/3%. Okay, and so now we have 2 cases depending on what happens. So in the first case, so A, if 2 or more different shares are bid on between the choosers, then shares can always be assigned fairly. And we'll see a bunch of examples of how to do this because there are several different cases. So, but there's always a way to do it by just saying, okay, you get this share, you get this share, you get this share. Now, part B, so the second case is a little more complicated. So if in the first case, we have two or more different shares bid on between the two. So maybe the first chooser bids on share 1 and the second chooser bids on share 1 and 2. So the combined total, they've bid on two different shares, 1 and 2. It doesn't matter which one bid on which, you have at least 2. Now, if that doesn't happen, then that means that both choosers bid on the same share. So if both choosers only bid on one and the same share, so in this case, they're both competing for a single share. They both say, I want this first piece, and only that first piece. So if they only bid on one and the same share, then see if they agree on, oh, sorry. See if they agree on which share is the least desirable. If they do agree, then that share goes to the divider. Because if they both think there's one worst share, well, the divider thinks they're all worth the same, and so the divider is happy with any of the shares. If they don't agree, then choose randomly one of the shares that wasn't bid on to go to the divider. Finally, in either case, combine the remaining shares. So combine the shares that didn't go to the divider and have the choosers do divider chooser on the combined shares. Okay, and so a couple notes on this. So first note, the bid lists are secret. So if I'm a chooser and someone else is a chooser, I don't see what they're bidding on as they're doing it. So maybe you could put it on a piece of paper and then reveal them at the same time. So the bid lists are secret and are all revealed at the same time. Okay, and so another thing is, it's possible in this case A, it's possible that the choosers may want to swap shares. If one chooser prefers the other chooser's share and the other chooser prefers the first chooser's share, then they can swap. If they both agree, they may do so. And finally, like I said before, it's very important that the choosers bid on every share they consider fair and not just their favorite. This can actually backfire, as we'll see in a future video. Okay, and so let's do a quick example. We'll see a lot more examples, but let's just do a quick one right now. So let's say we have, usually how this is going to go is we're going to have 3 players and we're just going to see all their values. So P1, we have 1 player, we have 2 players, and we have 3 players. Now we have 1 share, we have 2 shares, and we have 3 shares. Okay, and so the values are going to be as follows. Let's say P1 was the divider. So their first task is, so if we've decided randomly that P1 is the divider, it might not always be P1, but their job is to divide up shares S1, S2, S3, so that they're all worth the same amount, 33 1/3%. I'm not going to bother writing in the percent symbol, just for space. Okay, and so suppose maybe P2 thinks that S1 is worth 35%, S2 is worth 20%, and S3 is worth 45% of the total. And let's say now that P3 thinks that S1 is worth, or let's say 50% for S3, 20% for S2, and 30% for P3. Okay, so the divider has divided, and we can see that because all of the shares have an equal value for them. Now let's see, what is P2 going to write on their bid list? So P2 bid list. Okay, so let's go through each. The threshold, so needs to be at least 33 1/3% for a player to consider a share fair. Okay, so let's go through each. 35% for S1, well, that's at least 33 1/3%. It's more. So P2 would consider S1 to be fair. So 35. I'll use these squiggly brackets just because it doesn't actually matter what order. So when I use the squiggly brackets when the order doesn't matter. So S1. What about S2? S2 is only worth 20% to P2, which is less than 33 1/3. So P2 does not consider that share fair. And then finally, S3 is worth 45% to P2, which is definitely considered fair for P2. Now P3, bid list. And so again, P2 prefers S3, but would also be happy with S1. And so P2 has to make sure to write S1 as well because they also consider it fair. Now P3 thinks S1 is worth 30%. So that's not quite this 33 1/3%. So they don't consider that a fair share. 20% is even less. And just like for P2, P3 does not consider P1 to be a fair share. But P3 does consider S3 to be a fair share at 50%. Okay, and so now, step 2, the 2 players have made their bid lists. This is what their bid list would look like. They are rational players. They will say, all right, if it's at least 33 1/3%, I will bid on it. So we have the bid lists. And now, are we in this first case or the second case? So if first case is A, if 2 or more different shares are bid on between the 2 choosers. So between the 2 choosers, we have S1 and S3. So the choosers combined bid on S1 and S3. And so that's pretty bad. So they bid on at least 2 shares. That means we can always figure out, okay, we can always assign shares fairly. Try saying that 5 times fast. So here's our first rule that we'll see for assigning shares fairly. So in case A, if a chooser has only bid on 1 share, so if a specific chooser only bid on 1 share, give them that share. Okay, and then if there's and for the remaining shares, and then assign the remaining share. So, and then, yeah, if they only bid on 1 share, give them that share, and then assign from the remaining shares on the other chooser's bid list to give to the other chooser. Okay, so this is one rule to assign shares fairly. And so here we see P3 only bid on S3. And so we're going to give S3 to P3. And now S3 is out, we've assigned it. And so the only one left that P2 bid on is S1. That's the only one left in P2's bid list. And so we're going to give S1 to P2. And finally, neither P2 nor P3 bid on S2. Neither of them want it, but it's the only share left, and the divider is perfectly happy with it. So S2 goes to P1. Okay, and so here is a fair division. And the reason this works, just very briefly and very informally, the divider always gets one of the shares, and the divider is happy with any of the shares. So the divider always gets a fair share. Now, in this first case, we can always assign shares from the bid lists of the choosers. Okay, and so if we can always assign them from their bid list, well, they bid on shares that they consider fair. So if they get one of those shares, then they get a fair share. Now, in this last case, B, in the second case, one of the shares goes away, and this share, the share that goes away to the divider, both of the choosers agree that it's worth less than 33.33%. So that means the other 2 shares combined are worth at least 66.23%. And so when they do divider chooser on the combined 66 and 2/3%, then because divider chooser guarantees you at least 50%, they get at least 50% of that 66 and 2/3%. So half of that would be at least 33 1/3. So no matter what, everyone gets at least 33 1/3% of the total value. We're going to see more videos or more examples in future videos, but that's going to be all for today.